All right. Hold on. Good morning. Thank you for attending today's seminar, and I'd like to welcome you to the Ateneo de Manila Department of Economics and Ateneo Center for Economic Research and Development Seminar Series. For those of you who are regular, thank you for coming regularly to the seminar. But for those who are new, let me just remind everyone of our house rules. First, we will let the speaker finish her presentation first before we entertain questions. Zoom participants, kindly stay muted and stop sharing your video during the duration of the presentation. During question and answer, please virtually raise your hand and wait to be acknowledged. You may unmute and show yourself when asking your question. Participants on YouTube, you may post your question in the comment sections and we will read them out for you. Slide, videos, and other materials from seminar are posted on our website only when the speaker gives their consent for sharing them. And today, we are very fortunate to have been given permission to share the recording of the video after the seminar. By the way, my name is Maha Rabago. I'm Associate Professor at the Department of Economics, and I will be your host and moderator for the seminar. Our speaker for today is born and raised in Hong Kong. Her name is Professor Nancy Chow, who joined the faculty in the Charles Dyson School of Applied Economics and Management at Cornell in 1999. Professor Chow's research interests fall under three main areas: international trade, regional economics, and economic development. Professor Chow was recently awarded the Humboldt Research Fellowship of the Alexander von Humboldt Foundation and the first T. Schultz Award of the International Agricultural Economics Association. Congratulations, Professor Chow. She is a senior fellow at the Center for Development Research, a research fellow at the Institute for the Study of Labor, and she has visiting positions at Oxford University, ZEF, ISA, and the City University of Hong Kong. Professor Chow has published widely in journals such as Economic Journal, Journal of Development Economics, Journal of Economic Growth, Journal of Economic Theory, Journal of Labor Economics, Journal of Law and Economics, Journal of Public Economics, Public Economic Theory, among others. Friends, let us welcome Professor Nancy Chow. She's here with us to share her research on migration gravity with status quo bias and job search friction. Please join me in welcoming her. Professor Chow, the screen is yours.
Well, thank you so much, Maha, for the kind introduction. And I want to say hi to all of you who are here and who will be listening to this talk offline. And so let me just put up these slides for you. Let's see here. I think this works better. Maha, is this okay? Is everybody seeing my slides? Very good.
Yes.
Well, thank you. So, so I just want to start by saying thank you to Maha for the kind introduction, as well as for the invitation to give this talk. We met in DC just 3 months ago, and we talked a lot about migration related topics, and I'm so glad to be able to come and give this talk to you all. So the paper itself is joint work with Anna Basu and Gary Lin. The paper's topic is on, it sounds a little technical, but hopefully as I explain it to you, it would make sense to you all. It is about what is called migration gravity with status quo bias and job search friction. And so let me go to the motivation of this talk. Essentially, internal mobility in the United States, essentially to what extent people migrate between counties, between states within the United States has been low, and it has in fact slowed in recent years, despite the fact that geographical distance between people itself has not fallen, but I think because of social media, because of the reduction in transportation and communication costs, you would think that, right, the information distance between people would have fallen. However, if you look at the data, a simple table that I have for you here, across gender, across people in different ages, across people with different education level, despite the fact that between male and female, or between people who are working age or non-working age, right? The migration rates are different in a very reasonable way. So for example, those who are working age tend to be more mobile relative to those who are not. Those who are more educated tend to be more mobile, right? Across time periods, however, you see that in fact, these rates of mobility within the United States has not changed very much. And in fact, in many cases have fallen. And so here's a puzzle that that I think is important, not just because it is migration is an opportunity for people to find better prospects elsewhere, right? Particularly in times of tight labor markets where unemployment rate is low, huge demand for workers in some places, the fact that people don't migrate in search for jobs is an issue that deserves addressing. And so in a sense, this paper is devoted to understanding this. And so I will just jump to the first set of results, the first set of things that I think motivated me to write this paper. So the first result that we will show is that we will write a model, we will think about some reasons why this slow internal mobility might be going on. But essentially, the basic idea is as follows, that better communication, right, you would imagine because of social media, actually foster connections bilaterally between two places or even multilaterally between a number of places. However, so strong bilateral networks, of course, facilitate better access to jobs, right? You know a friend here, you know a friend there, you would be better able to find jobs in a different place. However, stronger network everywhere. If everybody has better access to jobs, that tend to lead to a more competitive labor market where, you know, with the same number of jobs being offered, it's much harder to find jobs. And so perhaps, right, the bilateral and multilateral effect of these job search networks is what's perhaps going to be able to allow us to think about why, despite the fact that social media is helping us to understand what's going on in the job market in various locations within the country, right, mobility has not increased. A second element that we will introduce in our talk today about why people maybe do not move as much as we think they should is what is called status quo bias. And so here I show you a picture of Ithaca, New York. So Ithaca is the city where I am right now speaking from. We're upstate New York. We are very famous for our waterfalls, our gorges, and so on. However, for people who have not been living in Ithaca, this will be a fact that you perhaps do not know very well. And so essentially we have a tagline, you know, this is called Ithaca is gorgeous. And so it's only known to those of us who are here, right? So as soon as you show up in Ithaca, and I hope some of you will, or some of you already have, you will find t-shirts like this everywhere, right? So we always say Ithaca is gorgeous. It's a pun, but it's also something that makes us feel that we're at home. And so this kind of status quo bias, that you only develop a liking to a place after staying in a place, and once you've developed a liking, you might not want to move as much, is what we call status quo bias. And here I list for you a number of other reasons why once you're in a place, you might develop an inertia to stay in that place, right? For example, information sometimes is only available for people who have been in a place for some time. There's also something called endowment effect, namely a tendency to adhere to a status quo more frequently than would be predicted by, let's say, a competitive or canonical model. Sunk investment that you might have put into, right, a home that you have invested in, friendship relationship that you have invested in, social capital that you might have, right, you might have invested in, that makes it harder for you to move to a different place, right? And sometimes, of course, because status quo bias includes information advantages as well as these sunk investment. These things can have both positive, sometimes negative impact on the incentive for people to stay in a place. And so status quo bias being something that is, I think, sensible so far has seen, relatively little attention in the economics literature. Rather, people typically think about the reasons for people's moving being a result of wage differences, amenities differences, and so on. And so another objective of today's presentation is to develop a framework so that we can estimate, we can find out people's revealed status quo bias, right? And so we'll show how to do that in an estimation that we will run. But furthermore, not only will we churn out numbers that correspond to county level status quo bias in the US, right? This is just the case that we apply to. Once you know the model, you can apply to any empirical setting you have in mind. What we want to caution is that failure to control for, right, a job search network, those social media connections that I was referring to just now, will show up as biases in our estimated status quo biases. And so that's one thing that is really important to know, right? So two things that I've started us talking about here: search friction, right? And secondly, status quo bias. Both seems to be things that, stop people from moving around. But the estimation of these things, right, as it turns out, makes both status quo bias and job search friction to be inextricably linked. All right, so having said that, I have two slides about what we do here, but I think I spent a little bit more time on the other slides just now. So let me just move forward to tell you a little bit about what we do. Two things. One is that we propose a new theory of the migration of individuals that is mediated by what I call job search network, right? And so in this model, we will have two main features. The first one is job search friction, and I'll define that more clearly in just a second. And secondly, status quo bias, that these things that you have invested in, that makes it harder for you to read, right? And the outcome of that theory is a gravity equation that I can use to estimate, right, the importance of job search friction and back out status quo bias from the model. Yeah. So for those of us who've been working on this area for some time, we know that this gravity equation assumes a very specific functional form. But without job search friction in models that have been out there for some time, there's no notion of unemployment because those people who want to find job always finds a job, right, in those theoretical constructs. And so the main import of what we're doing here is to have a new gravity equation in which, right, unemployment is a key part, right, of what we consider. Secondly, right, we also look at a pair of estimable migration share equation that is consistent with the gravity equation that I put forward, right? One is in terms of outflow, right? People who are migrating out, and the other is in terms of inflows, people who are migrating in. And we will separately look at the implications of estimating migration flow one way versus another. So that would be the theoretical contribution. The empirical contribution here is that we will estimate using US data on county level flow of migrants, both an outflow and inflow gravity equation based on a number of search friction or search intensity linkages. So the most canonical types of migration models takes into account distance or maybe same state status as a very basic, right, controls for migration costs. Right? And so then the story that we tell, the connection between people is actually really important. Nonetheless, we want these things to be exogenously determined. And so we will be using as proxies for job search linkages, historical ethnicity, historical industry of employment, and historical occupational proximity between any two locations as, right, as I said before, proxies for the connections between places. All right, so once I have that basic framework, we estimate using US data, and what we find are the following facts, right? First of all, county level status quo bias exhibit a wide range, right? We will see exactly how that works in just a second, with a median of close to 0. So if you think about it, 50% of the counties in the data that we have actually do not show any status quo bias, right? However, it really depends on the kind of search friction controls that you use. So if you don't, right, if you don't control for historical connections and whether it's through industry or ethnicity, we find that the search friction controls, we find that 50% would be the average status quo bias that we end up estimating. So this is really important. Geographically, status quo bias is highest in New York State, Virginia, Texas, and California. However, if we fail to control for search friction controls, right, we will find that the Rust Belt states, right, are also seeing high level of status quo bias. And so that's really an issue that we have to pay attention to. We have a number of other features in the model, other features that we can find that are correlated to status quo bias as well. These include the average age profile of a worker in the state, in the county, the share of college-educated workers, the political orientation of people, as well as religiosity, right? So how do these factors that are fundamentally non-economic in nature, goes into, right, affecting people's ability or incentive to move, are basically things that we're gonna uncover today, right? So having said that, there's some literature that are related here. I'm debating whether or not I should move ahead. But essentially, I think what I would like to say here on this slide essentially goes to show that in the existing empirical literature on gravity models, there are a number of correlates of migration, including, right, income, origin destination features, amenities, network effects, mobility costs, and climate. So these are all quite sensible correlates of migration. But what this study contributes are the addition of search friction controls, right, which include ethnic distance between places, industry, and occupational compositional linkages. In terms of contribution to theory, what I would like to say here is that there is a very kind of canonical model of the gravity of migration, which is based on what is referred to as the random utility model. What this study adds to that particular literature is to say that full employment is really not guaranteed as soon as we, right, begin to consider the fact that, there exists a search friction in the labor market. And so what we want to do here is to contribute to that literature in that way. All right, so having said that, here's the model. So there's a series of pictures, and so I would like you to think about these pictures with me. If you are a migrant in one of these places, what will you do, right? And so think of these circles. I just happen to arrange them in a circle, but consider these as counties or locations or jurisdictions, right? So there are M of these M locations, and in each one of these locations, there are people, and then there are jobs. Right? So NM is the total number of people in any one of these M locations. And VN is the number of job vacancies, let's say, available in any one of these locations. And so every worker in every location is trying to find a job, right? In any one of these locations, right? So people can migrate. I'm not stuck in my own location. The question is how many people are going to end up moving, right? So think about, pick one of these locations and ask yourself, what would you do? But of course, it all depends on the information that you have about any of these locations. So let's start from location M, right? I'm from M, this is my origin location. I can find a job within M, right? I can also find a job in another location, let's call that N or K, and so on. So in principle, I can receive job offers from all of these places. And so I need to have some way of thinking about what is the likelihood of getting a job offer from one of these places. And so here the model take advantage of what is called Poisson rate of job arrivals, right? And so at that rate, let's say a particular migrant obtains a Zn number of offers, right? And that Poisson rate depends on a number of things according to the model that we have drafted here. AMN is the connection intensity between these two locations. Let's say how well connected to friends you are to that in that location M. So you're from M, you're thinking about N. So that's the intensity of connection. But also it depends on the number of jobs available. So VN in location N, and the total number of people looking for jobs in location N, which includes you, location M, but all the other locations that are available in your country as well. So I'm summing them up, right? So jobs per worker looking for a job in N, right, times the intensity of your connection to that place is the job arrival ratio. That's it. So suppose that these are the givens, right? As a worker, you received ZM number of offers from location M. You receive a ZN number of offers from location N, and ZK number of offers from location K, right? So these are all occurring probabilistically. From each one of these offers, you take a draw. You randomly draw how happy you are about this particular place. Right? So this is the probability distribution associated with that. If you are drawing that probability distribution that it belongs to your own location, so if M is equal to N, let's say the probabilities distribution is just F, right? But suppose you're drawing a utility of staying in that place from a location other than your own, right? So when M is not equal to N, let's say we have Bn as a shifter of how much you like that place. And that's what we use to distinguish between somebody who has stayed in a location for a while, M equals N, and someone who is not. So M is not equal to N, you will have a Bn, which is a shifter of your utility distribution. Right, so all of this will become more concrete in just a second. So what we have so far is that you draw job offers. Each job offers gives you a utility. The level of that utility is taken from a distribution function, right? It depends on the distribution function, depends on whether you're drawing it from your own location or from a different location. So with that said, we have some calculations to do. First of all, we want to figure out, right? What is the likelihood distribution function? What is the probability distribution of the best offer, right, in a particular place, right? So at the maximal offer for somebody from N going to N, right? So here's a mathematical formula for those of you who recall, right? This is the probability distribution of the maximum, right, of Zn number of identically distributed random variables. Because of a Poisson distribution. So this is the probability distribution of the best in location N. The ultimate question that I need to do is to figure out, right, the maximum, so that I take the best offer from each location, compare all of them, and ask which one is the best out of the best, right? The likelihood that location N gives me the best, right, offer out of all the best offers in each individual location is mu mn, right? So, and then finally I use the law of large number to say that, well, if mu mn is the likelihood that location N gives me the best wage offer, then mu mn itself is the fraction of workers from location M going to location N, right? So this is basically the story here. Seems like a lot of notations, but as it turns out, one more thing will take us home. And this thing is the following assumption. We will assume that the distribution function of the utility of a job in location M follows a generalized Pareto distribution with a functional form that looks like this, right? Where Wn is, if you will, the average utility of getting a job in a location N. Bn is the shifter associated with status quo bias if you don't live in that place. Bn is equal to 1. I'm sorry, Bn is equal to 0 if you actually are originating from that place. And so a few more simply mathematical and quite mechanical steps later on, I have for you this particular equation here, which basically shows that the fraction of workers from location M going to N is really just a product of two terms. One is the ratio of, right, the relative importance of location N to everything else. I will explain what that is in just a second. And then 1 minus something else. As it turns out, this 1 minus something else term happened to be 1 minus the unemployment rate. Right, so that's basically what we have here. But let me get into detail about all of these terms in just a second. So this mu mn term, of course, is the migration ratio that we will estimate in just a second. Is made up of 1, 2, 3 important terms plus times 1 minus the unemployment rate. And so let me go into this a little bit in detail here. Alpha MN, as it turns out, is the status quo bias adjusted search intensity. Right? As I mentioned before, AMN is how many friends you know in location M. So that's just how connected two places are, right? Divided by 1 plus the status quo bias, right? Right. So what that means is that if you're from a location other than M, right, your search intensity is kind of discounted by a BN. So that's alpha here. Second, W is not little w, it's big W. What is that equal to? Well, as it turns out, it's little w times, right, a probability of getting a job term, which is equal to the number of jobs available in that location divided by the total number of people looking for a job there, right? So that's, these are the two terms that constitute, right, the likelihood of finding a job, the likelihood of migration from a location M to N in our model. The rest of it, of course, is just the unemployment rate. And so the main result in words, in other words, is as follows. Migration, of course, is the product of competing desirability, right? It's me, right? It's location N, one location versus every place else. Stronger networks between M and N, of course, these are bilateral links, makes migration easier. However, stronger networks multilaterally, right? So here makes migration harder. Simply put, there's just more people looking for the same jobs as you do. So stronger networks increases the number of job seekers in any N, right? So that leads to higher job competition. Finally, stronger status quo bias decreases alpha MN because unless you're migrating to your own place, right, migrating everywhere else leads to a discount. Okay, so I'll skip unemployment because the focus of today is on migration. And so if I use this migration equation, right? So this is a fraction of workers that go from M to N, and I stack two of these, one on top of the other, right? So this is mu MN, right? I will divide mu MN by mu MM or mu NN, right? So as you can imagine then, this term that is in the denominator, right, gets canceled out because otherwise estimation of just the migration likelihood between two places will need information on not just information between those two places, but multilaterally as well. And so in order to get around that difficulty, I have an outflow ratio, right? That is from our model where, right, the outflow from M to N, right, depends on the ratio of search intensities, the ratio of expected utilities, and the status quo bias term, right? It's very simple, right? So in terms of inflow ratio, right, the share of people coming into location N, right, depends on the same relative connectedness, relative employment ratios, and then also the same status quo bias terms. So you can see outflow ratio and inflow ratio from our model is very symmetric, right? So implying that both of them can be perhaps estimated in similar way. Furthermore, one more implication that we can draw from the model that we have written down is that this outflow ratio, in just a second I'll show the inflow ratio, depends on relative search intensities, of course, but also taking logs on both sides, right? I have essentially a origin destination fixed origin location fixed effects and destination location fixed effect. Right? Once again, origin location fixed effect when I'm coming from M, and destination fixed effect I'm going to N. Right? So as you can imagine, one, right, M and N, any location in a particular country can both be a recipient or an origin, and hence I can just find the back out the status quo bias of a particular location, let's say New York State or Tompkins County, which is where I am, by taking the difference, right, between the origin fixed effect and the destination fixed effect from the model. It's simply equal to the log of 1 plus the status quo bias. And so that is what we're going to be doing to back out the status quo bias as implied by our migration model here. right? So we can do it for the outflow gravity. As it turns out, with inflow gravity, one can do exactly the same thing here, except that, of course, the interpretation of these fixed effects are different. But once you take the difference of these fixed effects, right, you will find that it is what you can back out is the same status quo bias term, right? So with the basic idea, what we're trying to do here, I hope being clear, what I'm going to do is to take us to an estimation where we will estimate the migration gravity equation, right, with search friction controls, right? So our alpha mn terms, we'll be careful about the choice of these terms, and then we will back out the status quo bias term. So that's the exercise that we're going to engage in today. And so just want to introduce to you what are these search network indicators that we'll be using here, because we want to get around the issue that places that where people know each other a lot are also places where perhaps a lot of mobility takes place, right? So we will use exogenous, historical, ethnic, occupation, and industry relationship from 1940 census data. What we will end up doing is constructing a distance measure between two counties. Let's call them M and N as, right, this basically distance measure, right, a Euclidean distance measure, where SJM is the share of a particular group J in county K. So in the ethnicity case, it would be ethnic group J. In the occupation group case, it would be occupation J. In the industry of employment case, it would be industry of employment J, right? So essentially, I want to define how different two locations are in terms of their ethnic composition, industry composition, as well as occupation composition. That's this term. I will construct for each pair one such distance measure for ethnic, one such for occupation, and one such for industry. So that's the search friction measure. In terms of migration measures, we have bilateral county population flows, yearly counts of individuals who have moved between counties from the American Community Surveys from 2014 to 2018. We have unemployment rates from the same data set as well. We have information from 425 unique counties where the mean inflow ratio, as you can see, is quite low. Right, so having said that, what I would like to do is to show you some scatter plots of the relationship between each of our search friction measures, ethnic distance, industry distance, and occupation distance, vis-a-vis the outflow ratio in this case. I could have plotted with the inflow ratio as well, but you will see it in the paper. So what you see here, just in the raw data, these are bin scatter plots with same state controls, right? You see a natural downward sloping relationship, right? So the more distant two places are, the less the migration between the two places. The more distance, right, two places are in terms of occupational composition, right? The lower the outflow ratio. So ballpark, right? These things seems to make sense. And finally, what I have here is geographical distance. And this graph is distinctly different, right? And so what I can tell you is that this is 700 miles apart. Right, so an average distance between two counties in my data says is about 700 miles. And so what this is basically showing is that there's a lot of migration between nearby counties within a state, as well as nearby counties across two states, right? They're just adjacent to one another. And so lots of outflow between there. Thereafter, you know, the farther two places are, of course, the less the migration. And here you see a little bit of an uptick here. And so what I suspect is happening, of course, is that, you know, we have lots more migration between New York and California, right? So these bi-coastal migration. Right, so essentially two sets of regression data will run: outflow ratio, inflow ratio as a function of the search intensity controls. And search intensity controls will be based on ethnicity, occupation, and industry, right? Composition differences, right? Distance between two locations, as well as same state controls, right? In addition to that, we'll have destination fixed effect, origin fixed effect for both outflow and inflow regression. And so here's the result that I'd like to show you guys. So things are significant of the right sign. I think that is to be expected, right? The farther away two places are in terms of their connectivity, right? Whether it is because I know a family, friends and neighbors, or people I know, or in terms of colleagues that I know, or in terms of occupation that are similar to mine, all of these distances leads to less migration, right? So all that makes sense. Being in the same state is a huge booster to migration, right? With long distances between locations, this is a negative impact on migration. All this is done, right? Both for outflow and inflow racial regressions. But what I've also summarized here for you are the corresponding estimated status quo bias, right? So I took the fixed effects, destination and origin fixed effect for the same county, take the difference and average, take the average or take the median. And so what you can see is that, right, using only search friction controls, right, the median status quo bias is, very close to zero, right? Using only search friction controls, the median status quo bias is equal to zero. However, if I only use geographical distance, then forget about the fact that people need to know each other to help them find jobs. Then the median status quo bias is actually as high as 40%, as high as 40% here. So one thing to notice that in estimating status quo bias, we want to be very careful about being able to control for the network, right, connections that is essential for people to find jobs. So I want to show you a few ways to look at the status quo bias that we've estimated, right? So the first thing that I mentioned before is that these status quo bias estimates tend to be very dispersed, right? So as you can see here, we have very low values. In fact, some negative values all the way to high values of positive numbers, right? And so there are two of these that I've plotted for you here of the 425 counties. And so 425 different status quo bias measures that is being plotted here. The solid line depicts the one that is estimated using outflow gravity and historical search friction controls. The blue line, that's more spread out, uses distance control, right? So that explains the difference between 0 median and 40% median that we saw just now. Another way of looking at status quo bias is to aggregate to the state level and to see which of the states that we have here, in fact, has the highest status quo bias. And what you see here is the darker the color, the higher the status quo bias. And so I don't know if it's surprisingly or not surprisingly, right? California, New York, Texas, Florida, these are the locations with the highest status quo bias. We still need to figure out why that is the case, though, but that's coming, right? But these are estimated based on using historic search friction control. So we have already accounted for the fact that locations that are different from each other might turn out to be difficult for people to find jobs in. So you control for that. These are the states with the highest status quo bias. If you don't, right, if you only use geographical distance control, what you find is that, in fact, the Rust Belt state, these are the states of the US, right, that is referred to as Rust Belt state. These are the states where most of the manufacturing of the US takes place. And so these happen to be, right, these are revealed to be states that seems like they have high status quo bias. People don't seem to be moving as much as they should, when, of course, now that we have the previous diagram and this diagram together, perhaps we understand that there's estimation bias in this particular set of status quo bias estimate. More ways of thinking of kind of drawing out the intuitions that we can learn from these status quo bias. And so who or what type of workers might be more likely to stay in a location? So here it considers environmental considerations, right? So perhaps people who are nearer retirement would prefer, right, warmer climates. People who are living alone might have less family to support for them to migrate. And so in this diagram, we put both of these things together. This is the maximum temperature in January, and a percentage of people in a particular county that is living alone, right? So these things are being plotted, but the color, right, shows that the darker shades refers to higher status quo bias. So SQB stands for status quo bias. So perhaps not so surprisingly, with more people who are living, counties with more people who are living alone, counties that have higher temperatures, so perhaps more retirees, tend to have higher levels of status quo bias. Right? So that's one set of picture. Second set of pictures that I want to show you is that it is not just age, it is not just who you are, but sometimes it's the community that you live in that dictates what your status quo bias is. So here I plot for you a political orientation, the share of people in a particular county that voted Republican, right? So this is the Republican vote share. And so here are the Catholic rates of adherence per 1,000, right? And so you have a community of people that share your same religious belief or share the same political orientation as you do. What does that do to you insofar as your status quo bias is concerned? And so what you see here is that the more to the northeast you go, right? So the higher Republican vote share, the higher the level of religiosity, the higher the status quo bias. Right? So this is consistent with investment in your local political community, investment in your local religious community. And one more picture just to bring home the point that there's non-economic factors in play when we think about why people migrate or not migrate, right? Here's a set of information concerning, right, people's age, right? So the share of people are working age between 25 to 54, and people with an advanced degree, right, with bachelor's or higher, right? So these are, right, individuals that are more with whose opportunity cost of not moving, right, is much higher. And so as you can see here, closer to the origin you are, places where you have a stronger status quo bias. So places with fewer working wage population, places with fewer people with bachelor's or higher are places that, you know, is reviewed to have a higher status quo bias. Right, so with these in mind, I have one last table, but I must apologize. You know, one can't see too well here. But the last thing that I did that we did in the paper is to find lasso, use machine learning techniques to find predictors of status quo bias based on a long list of variables that one can think might be correlated with status quo bias. The full detail is in the paper. But what I would say, what I will just briefly say is that what we saw just now being important, right? Temperature, religiosity, and vote counts, and so on. They all matter, but in fact, there are other things as well that are shown to be important, such as commuting costs, population density, housing conditions, and so on. These are all things that are important. That previously. Perhaps these have not received as much as attention in the migration literature as they should. So just to conclude, I look forward to a conversation with you guys. What we have presented here is a theory-based, right, measure of status quo bias in the hopes of trying to explain why there is relatively little mobility between locations, despite the fact that spatially speaking, right, each location might be so different in terms of unemployment rate, average wages, amenities, and so on. Why don't people move? And so in our exercise, what we try to do is that two things might be at play here. First of all, there might be genuine search friction that is making it difficult for people to find job-related information in another place. Secondly, there are perhaps also non-economic, right, considerations that we need to take into account. And here we try to get at what some of these issues might be by estimating what we call a status quo bias. And so hopefully by doing so, we have provided some novel perspective as to why mobility and unemployment rate can be slow to adjust, even as people are getting more and more connected socially. The one more thing that I would like you to take home with you is to think about this notion of status quo bias more carefully as we think about, should people move more, or should people perhaps continue with their prior investment in social capital, in housing, and so on, when they consider their mobility decisions going forward. In any event, this is what I prepared for you guys. I look forward to conversations. Thank you.
Thank you, Nancy. That's really very interesting. Okay, so we now open the floor for discussion. If anybody have questions, okay, let me just check. Okay, let me just switch my view to gallery. Anybody has questions? Okay, I can't see. Okay, let me see now. Anybody? Still warming up. But it was really a very interesting presentation, Nancy. I just wonder what's the applicability. I mean, how do you apply this with international migration? I'm sure the audience also here would be interested to see. I see some people working on migration issues. Like, what would be the the angle on the status quo bias when we think about international migration? Because in the Philippines, there's a Filipino diaspora. Filipinos are everywhere. So how would you think about that? And I don't know if you have done or applied this model with international migration.
Yes, yes. In fact, I think it would be an amazing opportunity to apply this to an international migration context. Essentially, the story is really very much the same. Namely, your ability to migrate to a place. So two things that has been highlighted here is that a worker's ability to migrate to a place, of course, depend very much on the network that enables a job search to take place between two locations. And so good controls for these job search network is very important. And so one thing that I haven't shown because of time constraint here is that it is actually in the conclusion of the paper, is that I wanted to relate these historical search friction controls with Facebook data. And so how many friends do I really have in a particular place and so on. So as it turns out, Facebook connections between two locations are very much dependent on these historical search friction measures. And so first of all, controlling for search friction is important. Second of all, in order to find out whether perhaps a worker in the Philippines decides to migrate to Hong Kong or decides to migrate to China or any other place, right? One needs to think about not just the wage benefits that one gets by migrating, but one also has to think about, right, what are some inertia that might compel a particular worker to stay back. And so these inertia in the setting that I talk about, is kind of the unit of analysis is a county, but one can also think about a unit of analysis as a person. So in that case, what are some of these inertia factors that make a person want to stay in their location and therefore not able to take advantage of job opportunities that might pay a higher income or a particular location with a lower unemployment rate. And so some of the things that I've pointed out here perhaps might be of interest, and I don't know if that might make let your imagination kind of come to the fore. So some of the factors that I've shown here is that living in a place with people that share your political belief, living in a place with people that share your religious belief, living in a place with people who are working age and so on. So all of these are factors that are perhaps not emphasized so far in the migration literature. And so I think when applying this particular setting, right, the theoretical setting to a different country, what we will be able to find out is whether the same set of things that are important for status quo bias in the US, let's say, would be equally important, let's say, in the Filipino context, Hong Kong context, and so on. So international migration is a big thing now, and so So I wonder what some of you who are listening here might think. But yes, so that would be my first kind of knee-jerk reaction to your question, Maha.
Yeah, and like what would be the trade-off between, these economic factors that push people to migrate versus this non-economic factors, especially in a country where you have a lot of unemployment and underemployment. That would really be an interesting extension of this study, Nancy.
Yes, and so in fact, in addition to the U.S. case, no, so it's really important. So in terms of applying this setting, it is really important to find good migration data that is bilateral. It is
Mm-hmm.
important to have good search friction data, right? And so it's for different countries. These should vary by context. And so I invite those of you who are in the audience to think about what are some reasons why here I am in Manila, maybe it's very difficult to find a job in a different city, and so on. So what are some of these search friction control that is important to you? And so be able to kind of use these things in your applied work, I think is very important. So one location that one set of locations that I am beginning to start work in is actually Europe,
Mm-hmm.
where in fact, friendship network data through Facebook is also available in a kind of disaggregated level, and so hopefully that would be my next project.
That would be good. Let me now open again the discussion or comments and suggestions or questions from the audience on Zoom. Anybody? You may write your question on the chat box if you're shy to show your video or to open your camera. Let me see if I see some hands. Rainier, do we have questions from YouTube?
No, ma'am.
Okay. I also see people from the abroad, no? We have guests from other universities abroad. If you have questions, please, we welcome your questions. Anybody? I think people are raring to go to their classes. It's also class time. But in any case, yeah, we don't want to keep you. I know it's already like late at night where you are, Nancy. But before we end, I'd like to first take this opportunity first to invite everyone or to let you know where you can get materials, okay, from the previous seminar and also this seminar. You can get it from our website. It's shown on the screen. And then I would also like this opportunity to let you know that recordings of previous seminar and also today's seminar can be found in our YouTube channel here. You can get this and you can find all the seminar in our YouTube channel. And finally, let me invite you to our next seminar on September 27. This would be on blackout, the role of India's wholesale electricity market, and our speaker is Dr. Luis Prionas. Okay, and if you request for certificate in attending the seminar, Aya and Rainier will be sending the link to the chat box, so please do request. And finally, I would like to invite you to open your video so that we can take a photo with our speaker today. But before that, please let me acknowledge Rainier and Aya, our graduate assistants who's assisting us in the organization of this seminar, and also our IT support, Rudel Crisostomo. So thank you. So now, please, okay, I invite you to open your camera so we can have a photo opportunity with our speaker. Rainier and Aya will be helping us in taking the photo. So please open your camera. Rainier.
Okay, so let's give everyone a few moments to open their videos.
Good to see you all. Good morning.
Okay, so I'll be taking the photo in 1, 2, 3. One more time. 1, 2, 3. Okay, thank you very much.
Thank you. Thank you, everyone. Thank you very much, Nancy. Please join me in thanking Nancy.
Thank
Thank
you for
you.
having me. Have a wonderful fall term, everybody. Nice to meet you.
Thank you. Thanks, everyone. Have a good day. Bye.